So just as a gentle reminder here, some of the assumptions that we've been using, again, such as normality of our errors, the assumption that we have equal variance in those errors for different values of x, as well as having a sufficiently large enough sample size, these assumptions have gotten us pretty far. And as a result of that, some pretty nice things that we have from that are the fact that we can calculate valid standard errors. This allows us to get valid confidence intervals. This also, again, allows us to get p-values, and really the creme de la creme of what we want, right, is we're conducting hypotheses tests, and all of these other components are sub-elements of the steps that we have for a hypothesis test. Now, this is when these distributional assumptions are met, again, like sample size, but what happens when these aren't met? So to start, we can think of what happens when these aren't met by thinking of the counterfactual. So what happens when they are met? Now, again, a very simple example here is if we have an estimate of a mean from a sample, that'll be x bar, we want to make an inference of how close that is to the actual population mean, right? So when we define a statistic, in this case, we're going to use a t-statistic, right? Because we're trying to see whether or not our sample mean is different from or equal to the mean that we actually think exists in the underlying population, right? And so with normality, when we use a t-statistic, we know that this is going to follow a t-distribution, and when we have a large enough sample size, right, when normality is going to kick in, that allows us to construct valid confidence intervals, which allows us to compare, right, that p-value to a critical value, our alpha, which is us conducting our hypothesis test. Now, when these aren't violated, we're not going to be able to assume that t has that distribution, right? And if we don't know the behavior of that random variable, we're not going to be able to make any valid confidence intervals around that parameter of interest. And we're not going to be able to run a hypothesis test because we don't know the error rate, right? Now, and when I'm talking about the error rate, I'm talking about like how we actually calculate type 1 and type 2 error, right? If that t statistic isn't following those underlying distributions. So if we don't think that we're actually, we don't have a large enough sample size, we don't think that that distribution can just be assumed to be random, what are we going to do? Well, we're going to introduce a new type of approach, and that's going to be called bootstrapping.